All right, guys, it's time for the final project of today. And the goal is to be able to write some code here in Reborg's world to be able to get our little robot to be able to navigate to the goal and go through a maze no matter what the maze looks like. So if you go back to Reborg's world, if you already got a link open, if you don't, then simply click on the direct link in the course resources and it should take you here. And we've got the maze selected in the drop down, which is right here. Here we have a maze, and even though the maze doesn't change, the robot does. The direction that the robot is going to face is completely random. The position of the robot is also random, so you can see every time I restart the game, it will face a different direction. So in this case, it's facing up, but the next time it might be facing down in this case. And it's also always going to start at a random location in the maze. If you click on the world info, it'll tell you that the secret to getting the robot to complete the maze is to get it to follow along the right edge of the maze. If it starts anywhere in the maze and it just continue following along the right wall, it should eventually get to the final destination. For example, like this. Now, in this case, the robot is not making a beeline straight to the exit as if it could see what we can see, but it is following a strategy, or rather what you would call in programming an algorithm. And the algorithm here is to simply follow along the right edge of the wall, and if the right side is clear, then continue going right until it's no longer clear, at which point it should just go straight. And if you can't go straight and you can't go right, then the last option is to turn left. It's almost like the robot is getting a set of instructions in terms of hierarchy. The most important, telling it to turn right if it can. If it can't turn right, then go straight ahead. And finally, if it can't turn right or go straight ahead, then to turn left as a last resort. So you're going to need to use a lot of the functions that you saw previously, such as move, turn left, and testing whether if the front is clear or the right is clear, or there's a wall in the front or a wall in the right, and whether if the robot is at the goal. Think about how you can use a while loop and also the conditional if, elif, else statements to achieve this goal and get our robot to be able to go to the final destination no matter where it starts out and what direction it's facing. Pause the video now and try to use what you've learned to complete this final project. All right, so did you manage to complete this challenge? If not, let's work through the solution together. The first thing we need to do, which we've always pretty much needed completing each of these challenges, is we need a way to turn right. So I'm not going to type it all out again. This should be already pretty clear. Turn right is just turning left 3 times. Now, the next thing we need to do is we need to tell the robot to do things and to check for things until it reaches the goal. We know that we have this test called at goal, so we can use a while loop to get the robot to continue working until it reaches the goal. To define that, we could say while not at goal. So basically keep repeating the instructions inside this while loop until at goal becomes true and not true is false. So once this condition becomes false, then our while loop stops. So what we were told in the world info is we should follow along the right edge. We should test to see if the right side is clear, and if it is, then we should turn right and go straight. So that basically means moving right. Let's use an if statement to test if right is clear. And in this instance, so in this if block, we're going to say, well, turn right using our pre-built function up here. And then once you're facing the right, then move forwards. This should achieve a right move. So from here to here, for example. Now let's test this and see what happens. In this case, the right is clear, so it moved right. The right is not clear, so it doesn't know what else to do, and it's now stuck in what we would call an infinite loop. And it will never stop until the browser actually forces it to by crashing. So what we have to do instead is we have to provide an alternative condition. When the right is not clear, what should it do? So we're going to provide that condition by using an elif statement. And what we want to say is, if the right is not clear, well then maybe you should check if the front is clear. And if that is the case, then simply just move forwards. Now, this would work unless we're in the situation that we're in right now, where we're boxed in and the only side that's clear is actually the remaining one, which is the left. That's why we have to put in the last line of code, which is going to be an else statement. So in all other conditions, when the right is not clear and the front is not clear, so once both of these have been checked and they're false, then actually just turn left. So now you can see that when our robot is able to go right, it will try to follow along the right wall, but when it can't go right, it'll go forwards instead. And when it can't go right or go forwards, then it's going to turn left, and hopefully the next time it checks the loop, the front will be clear and it will be able to move forwards. So notice how our robot is somewhat haphazardly navigating through this maze, but it is following the algorithm that we specified, which is to follow along the right-handed wall until you reach the goal. And that's what these few lines of code does, using our while statements, our if, elif, else statements, and also our turn right function. There you have it. You've now completed day 6. So congratulations on getting this far, and I'll see you tomorrow bright and early.